Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hey folks, welcome to Making Data Simple. We appreciate you being here as always. Thanks to our producers. They are the best. Kate Main, Steve Templeton do a fantastic job. Thank you guys. Today we're going to be speaking with Orr Danon. He's the CEO at Hailo Technologies. Hailo has developed a ton of breakthrough deep microprocessor based architecture. It enables edge devices to run sophisticated deep learning applications that were either in the cloud or maybe on big processors or whatnot. To give a little bit more about Orr, he's led some very complex, what I would call interdisciplinary projects within the Israel intelligence community, managed the Israel Defense Award for the President of Israel, had a Creative Thinking Award for the head of military intelligence. We've got a lot to talk about today. But before, I'm going to give a little bit more insight here, guys, if you allow me. Hailo is an AI-focused Israel-based chip maker. Like I said, they developed a specialized AI processor that delivers the performance of a data center class computer to edge devices. They're rethinking, as they would call it, traditional computer architecture, enabling these smart devices to perform sophisticated deep learning tasks such as object detection and segmentation in real time with minimal power consumption, size, and cost. So essentially, they're designed to fit into smart machines and devices. The company was founded in 2017 by members of the Israel Defense Forces Elite Technology Unit, which we could probably spend the whole time talking about right there. But we will talk about Hailo. I think this is important to me for a number of different reasons, but some metrics I have from 2019 is the AI chip market is currently valued at $7 billion, but it's forecasted for phenomenal growth in 4 years from 2019 to $90 billion. So this is a very interesting area I've been wanting to talk about for some time. I've got the right person here in Orr. Welcome, Orr. Thank you for being on the podcast.
Thank you, Ed. It's a pleasure to be here.
So you're in Israel, I presume?
Yes, I'm in Tel Aviv.
In Tel Aviv. I've got a team in Tel Aviv that just joined our team in Expert Lab Services here, so know much about Tel Aviv. Give yourself a little lead in. I did the best I could there, but you have a very interesting background and experience. Could you share some insight on your brand, your background, and what brings you here?
As you mentioned, started Hailo a couple of years ago, targeting to kind of address what was already pretty obvious back then, migration of AI workloads from cloud to edge devices, where the main challenges is to take all the really great applications that you are looking on in the cloud, running them on reasonable size, power consuming, and priced processors. Already back then, it looked like a big challenge, and it looked like there's going to be some need for a really fundamental shift in computer architecture. I think that's really well established today throughout the whole industry. And when people talk about processors for AI, everybody's understanding that they need to look differently. We're now starting to see the fruit of these different lines of thinking, of different architectures coming into the market and showcasing what a big difference that can make in the ability to have AI applications actually running at real-world applications.
So look, there's a lot to dive in here. I'm very interested in this, as previously stated. I have a background in data and AI and some in hardware. I've done appliance hardware, and I've got software that runs on the edge. One of the best databases in the world, being Informix, kudos to those folks out there, does this. But it sounds like what Hailo Tech is offering a monitoring agent that collects data from edge device and then applies deep learning to the device. Is it hardware in nature? Is it a pure hardware solution? Can you give us more insight there?
So what we're doing, we're building processors. That means we're building both hardware and the software that enables you to run on that hardware. We've been used to thinking, since we are working with RISC processors and very specific subsets of families of RISC processors throughout decades is that the software comes on top of the hardware. And the structure of the hardware is pretty much given. Of course, we're improving it from generation to generation, doing more prefetches and branch predictions and everything. But AI is really made concept of what we all like to talk about of hardware and software co-design really critical to make something. So what we are doing, we're basically building a processor that can run on edge environments and digest data, run neural networks that digest data. And you might ask yourself, why would you want to go to edge computing in the first place? Basically, the reasons to do it, they come from a combination of different vectors. The dominant ones that we see from customers are bandwidth limitations. So let's take, for instance, smart cities, where you have in a modern city deployments of hundreds of thousands of cameras collecting data. That is used to manage city, for public safety, for traffic control and everything. So that's tons and tons of data that you want to collect, but you don't really need all the feeds from all the cameras. It's really expensive also to transfer all the data to a cloud. What you really want to transfer to the cloud is a digestion of the data. So you don't really need the full bandwidth of moving 4K video to the backend, but you rather need to digest it locally, and then after it's concise data, move it to your cloud environment. Another set of considerations relates to latency. When you have an edge device that acts on the data, let's take for an instance, everybody likes to talk about autonomous cars, but let's even take industrial automation, where you have a sorting machine that looks at a conveyor belt and sorts goods. The faster you respond to what you see on the camera, the better the throughput of the production line is. So that's latency considerations. And of course, when you're talking about things that are moving themselves, like cars or robots, of course, they need to respond in real time. Third motivation is, and it might be surprising from a cloud perspective, is cost. We tend to think about cloud as a way to reduce costs since we can do amortization of data processing. The idea is someone is processing at moment A and someone is processing at moment B. We can use the same hardware to do it, and therefore we can share the cost. And when you're looking at processing video signals, it doesn't really work this way because you're doing continuous work. And it's actually pretty expensive to process video at the cloud. It makes a lot of sense to actually do it at the edge. So these are kind of functional reasons for wanting to move from cloud to the edge. There are other reasons which are more, I would say, in terms of policy. And there are a group of things that relate to security, whether you want data to be accessible outside the edge device. It can be privacy, most notably GDPR regulation, and it can be liability or resilience, of kind of asking the question of, let's go back to the example of industrial automation. If, let's say, there's a communication breakdown between the factory and the server in the cloud that processes the data from the factory, and the production line is stopping because of problem in communication, who's liable for that? So this is kind of a very simple reason for wanting to have everything concentrated at the edge where data is being sourced and being consumed.
This kind of reminds me of a article. I think it was it was just an article. It was actually entitled, I think, Return to the Edge and the End of Cloud Computing with Peter Levine and Anderson Horowitz, in which case they were pushing the idea that as we head to the future, more and more of the compute, as you mentioned, it's going to be digested locally and then at the edge, and then pushed, only what you need is ultimately pushed to the cloud. What I hear you saying is essentially this is the strategy that you're essentially promoting here, trying to do as much computation at the edge itself, given the amount of data we're talking and the performance that we need, and then only pushing what you absolutely require to the cloud. Is that a simple summary?
Yeah, I think that kind of summarizes everything. I don't think it's the end of cloud computing. Absolutely
I know.
I think it will only enhance cloud computing, actually.
I know, I agree. Well, I think that was supposed to be a shocker headline, right? The end of cloud computing to make you read it, but it was really just to push that there's going to be a lot of focus at the edge, which, to be honest with you, or is still, I've said this before in this podcast, it's still nowhere where I thought it would be by this time. Hell, we're at 2021. I mean, I would imagine we'd see more smart cities, and I still get into it. Well, I'm not traveling right now like most of us, but when I was traveling, and you get into a hotel, I mean, they're not as smart as they should be by now. It seems like we're still behind. I don't know if you have a comment there, given you're in the business, but it's still like we've got a huge upside, and we haven't even scratched the surface.
Yeah, I agree. We are barely scratching the surface. And I think some industries are moving faster than others. Already now you can tell that looking 2 or 3 years into the future, I expect at least half of, for instance, cameras will have AI equipped on them. And I think we already see the market starting to move that direction, being pushed by applications like security surveillance, which is very clear, retail, smart cities. I think any project that is looking at deployment in the coming year or two is not going to do it without significant AI video analytic capabilities. On the other end, there's the question of whether we have the tools to actually do that at scale. And that relates to the challenges that I mentioned before. I mean, if everything is going to be based on the cloud, then we will not get to that vision that you've described. And that's part of what we are trying to do, is to give enablement through processing capacity to doing these things, these amazing things that you see running today on data center, being able to actually run them at the edge.
Before I move on, where do you think the fastest growth in the edge is going to be? I mean, I think I heard you say retail, cameras, smarter cities in the next 3 years. Anything else? And conversely, are there areas that you think are going to be extremely slow to the edge?
What I can tell you from our perspective is that the movement toward adoption of AI is actually much, much wider than the obvious use cases that we've just discussed. These are the kind of obvious ones. But when you look at the wider, you see active work being done by companies on medical and personal healthcare. You see it being done on drones. You see it being done on all kind of last mile delivery robots and the derivatives of that. Robotics, which are being used in different consumer and enterprise applications. You see it in defense in aerospace. You see it being implemented into heavy machinery. So you're actually seeing very significant players in all of these industries designing their products today with significant AI capabilities. Regarding who's moving slower, that's a good question, actually. From what I am still waiting to see in large scale is AI that is incorporated into televisions. I think we're still slow in that sense. There are many really cool things that can be done and are not being done yet. Another area which I think is moving slower than expected is AI in automotive, which is actually a very obvious use case, but pretty complex. Things are being incorporated. I expect it to be actually much faster. And I guess it's related to the fact that the whole topic of autonomous driving is taking a bit longer than many have expected.
So look, nerd out with me for a minute here. Let's back to your AI chip. What makes your AI chip different? Because there's a few out there. I know about GPUs, graphic processing units. I would imagine it's highly parallel. I don't know. What makes your chip different that is both very suitable for AI implementation, but also on the edge?
When you look at the bottom line, and this is thing you can find on the website, we're showcasing around 20x in power reduction compared to products like GPUs. And this is very significant. when you look at deployments at the edge. I mean, of course, lower power consumption comes with a smaller form factor. And these are all, you mentioned you're designing appliances in the past. So I think, for instance, we're going back to the retail example where you have usually a setting where 4 or 8 cameras are being aggregated into an edge box. And preferably that is an edge box that is fanless. It should be a fanless appliance if you want it to be easily maintainable. And the 20x in power reductions takes you from, 30, 40 watt system, which needs huge fans and active cooling and everything, into something that you can actually stick on the wall or in a cabinet or something that is very simple to manage. What we bring to the table, a really significant improvement in the power consumption on one hand, on the other hand, a very high performance. Being able to process high resolution videos at real time and multiple streams is something that is really relevant for all these fields. You might ask, okay, you know the world of processors. Usually when you look at the generational improvement, it's 20, 30%. 20x is a bit more than that. And fundamental approach that we've taken is we are looking at neural networks. We're not looking at general AI or something that is general. We're looking at neural networks. This is the real thing. And we view it as a data flow problem rather than a decision-making problem. That's the way that traditional computers were designed to make lots of decisions. And when you look at neural networks, they're actually more described as a way to flow data. And then based on the values of the data that is flowing, these are your interpretations of what the input to the networks is seeing.
So let me see if I restate. So, we're talking 20x power reduction while still maintaining performance. The difference in Lee's philosophy is your company's looking at the chip as a data flow problem versus a decision to be made. So that puts you in more the deep learning neural networks, essentially kind of the way modeling itself after the human brain. Anything else that you're able to tell us is your secret sauce that makes you different?
When looking at this as a data flow problem, you're not looking at this as a sequential calculation. And that is, I think, the fundamental difference. When you look at CPUs, GPUs, DSPs, what have you, they're looking at this graph of computation. They're actually computing it node by node. What we're doing is a distributed computing paradigm. We're distributing the compute along our processor rather than concentrating in one highly parallelized, very high frequency core. By doing this and building lots of very small elements that pass data from one to another, you're significantly reducing the power consumption because data is not moving back and forth all the time. And this could only work for neural network. This is not a general purpose approach of you cannot run C code on this kind of machine, but it is very well suited for algorithms that are described by the way neural networks are described.
2 questions. So if I'm a customer right now and I say, look, I'd like to see a proof of technology, I mean, what do they do? I'd have to get with you early on in my device manufacturing, would I not? Or no, are there different ways to proof of technology this? The other question, I don't know if this is related or not. Your chips work together at the edge? I mean, like, to your point, if you had, 100,000 cameras, are you designed to work at the edge together in concert with one another, or is each an independent entity?
So the easiest way to start, and that's what most customers do, is we offer chips. That's like the main thing, but we also offer M.2 PCIe M.2 modules that you can plug into any slot that you have for an could be used for an SSD or Wi-Fi or whatever, and you plug it in, standard environment, and you can start deploying your networks. And what most customers will do, they will start by looking at all kinds of standard benchmarks, which we publish and provide them also together with the software tools. And first of all, many don't believe that we actually reached the performance and power level that we're talking about. So they want to verify it. That's fine. We like being verified. And afterwards, they go and look at their more specific workloads and see how robust your software environment is. It's really easy to deploy their models. And this is another, of course, important factor. We are a chip company, but more than 70% of my workforce is embedded in software engineers and machine learning engineers who are actually working on the tooling that allow you to work easily with the architecture. This is a very significant part of our engineering management, is to continuously improve and make the process always smoother and easier to implement. Now, when you're looking at what your question on how does it scale up? So first of all, yes, devices can work in orchestration to a certain extent, but actually I think the direction in which you're pushing this question is actually trying to build a small cloud. You know what I mean? I mean, if you're looking at 100,000 cameras and say, okay, let's try to build a really big cluster that will process all these 100,000 cameras, then maybe you already have that cluster in the cloud. And what we are offering is actually something a bit different. Look, you don't need to aggregate all the way up this tremendous amount of feeds. Look at a lower aggregation level. It could be single camera, it can be 8, it can be 32. People like to work with these numbers and digest the data there. Architectural level, only when you've digested the data, then take it to aggregation and concentration of the next step, where you have everything together. That will probably, by the way, be either on-prem or in cloud, but it will look like more traditional server-based deployment.
What about security? You mentioned it earlier. Security, I mean, there's been a lot in the press around some of these chips that have security vulnerabilities. How are you preventing your chip from any security issues?
Like everybody, we follow try to follow standard safety procedures and standard safety mechanisms. In this sense, we are very, I would say, similar to any other embedded device. We use the same ecosystem and same mechanisms on signing, on input, and everything that everybody is doing in that sense. And is, of course, always true in security. You're only as good as your weakest link. One of the benefits of having data processed at the edge is actually from security perspective. The links in which you're looking, which are exposed to the data, are being limited, and they don't get up in the network to the aggregation point where you have all of the data vulnerable at one point. And this is one of the, I would say, driving forces that why people want to go to edge computing.
Tell me a little bit about the data. We are making data simple, even though we go everywhere. Trust me. When you're at an edge device, you're collecting tons and tons and tons of data. And the edge devices are getting more capable of holding tons and tons and tons of data. The amount of data we're talking is just enormous. Can you talk about a little bit more how your chip makes that more efficient so there's less requirement for third-party storage devices, hence the cloud?
The main philosophy that we are suggesting is not store the data at the edge and then move it to the cloud. We are rather offering the process data at the edge. And that means, it's very simple. Either you can sustain the rate of information that is coming, or you cannot. If you cannot, then you'll start accumulating the data. If you can't process the data on the fly, then you're not creating large amounts of data. Hopefully, you're creating smaller amounts, but of much more valuable data, which then, of course, will go to the cloud. But ideally, what the whole promise of what we're suggesting is that you process data on the fly and you never accumulate it unnecessarily.
Makes sense. Hey, who's your biggest competitor? Is it the Googles, the Apples, the ARMs, the Intel, NVIDIA, AMD? Who are the competitors as you see them?
The two, I think, families of AI processor for the edge that are dominant now that we see in the market. One is, of course, NVIDIA, which has a great lineup of products. It is the Rolls Royce, and it's really easy to work with and very flexible and relatively powerful. Problem, of course, it's not always affordable for many applications, and it's very power hungry. But if you look at from a software developer's perspective who says, okay, I don't care about cost, I don't care about power, I don't care about size, I just want this to run. And this is a very important, I'm not dismissing in any sense, this is a very important phase in the development. Then this is I would say, one of the best choices to make. But when you're looking at deployment, now you're saying, okay, now I do care about power consumption, I care about size, I care about cost. Then this is where we are offering a better alternative. From our perspective, we always look at NVIDIA as the golden standard for how things should work functionally. From the other end of things, we have products from companies like Intel, based on their Movidius acquisition, and Google with their HTPU. These are products which are much more suited for the edge. However, they're very limited in performance. So this is the other extreme. And depending on where the customer comes from, first, this is how I want things to run, like they are running on this very nice and shiny and bulky GPU, but let's squeeze it into something more compact and efficient. Then we'll be looking at NVIDIA. And from the other end, they're coming from, okay, this is the budget, this is the size, this is the power consumption, but I need more performance. Then usually we're looking at products from either Intel or Google.
Intel or Google. That makes sense. I presume Hailo are you VC funded today?
Yes, we're backed by venture capital. Also backed from the European Horizon 2020 program in the Israeli Innovation Authority.
Where do you think this will be in 5 years? Are you going to be the next NVIDIA, or are you going to be with NVIDIA?
So we hope to be the next NVIDIA. I think if you look at the retrospective, we're entering a new era in semiconductor, and everybody's talking about it. And I think these are not just words; this is a real revolution. I recently saw an estimate from Applied Material that we are entering a decade in which AI will increase the semiconductor market by $500 billion, which is equivalent to the amount that was created in the PC revolution and the mobile revolution combined. And I think that every time there was a tectonic shift like this in processing, new players emerged. And they were never the players that were big before that shift. So we certainly hope to be one of these new players.
I know you kind of mentioned this earlier, kind of subtly referred to it, but give us some practical applications that are being achieved today using Hailo's technology.
A few examples that are dominant. Well, one is retail. Okay, so looking at the shopper's behavior and preventing theft and optimizing the floor space. These are all interesting things that people are actually doing today. The field of robotics is moving fast, whether it is for enterprise applications or whether it is for more consumer-oriented devices. These are things that people are actively working on today, and they need lots of perception, and this is where we come into play. Another area which is adopting is industrial automation. So think, for instance, on a pick-and-place arm or a quality inspection at a production line. These are all things that people are doing today, and they're using AI for it. It's a really wide variety of these applications. It's for me, as a CEO of a processor company, I'm always very curious when a customer comes out of nowhere and presents their use case. And I say, wow, I would have never thought about this application. And I think this is kind of a testimony to the innovation, the way of innovation that the AI is bringing to many sectors, very, very large list of sectors.
I would imagine. Where can folks go to learn more about Hailo?
You're more than welcome to visit our site, www.hailo.ai. You can see product offerings that we have, take a look at our software and hardware, And if you're interested, contact us and we'll be happy to work with you.
I have a few more questions, just fun questions. But before I head into those questions, anything that we left unsaid? Anything else that you said, well, I wish I would have asked this question, or here's an answer to a question you didn't ask?
No, we got it all.
All right, we got it all. Sounds good. All right, so here's my first fun question. How in the heck do you make the leap from the public sector, meaning the Israeli Defense Forces, to the private sector? What does that look like? How do you make that leap?
It's easier than you think. In some senses, the people tend to think about the military as a very organized organization. The Israeli army doesn't look this way, and the intelligence certainly doesn't look that way. And the culture is very open and very informal. And that is very much how a startup in many senses. There's one thing, by the way, that you lose when moving from public sector, especially in a country like ours, to a private sector, and that is something that is almost irreplaceable in waking up and knowing that you're doing good to your country, to your people every day. In the private sector, you know that, you're basically doing good, but it's not the same. It's something which I actually miss from the public service. Working for undoubtedly working for the greater good.
Seamless transition then. Is it something that was in your mind and you said, look, I'm going to make the change and start this company? Or, how did it go about, though? If you could tell us just a little bit more.
I've been over a decade with the Army, and really I've been lucky to be part of really interesting things, being involved in lots of really interesting activities. But at some point, I realized that not getting excited enough anymore, and I decided that I need to move forward. And actually, really eager, being part of a very large organization, go and do something from scratch, something that struggles for its life and needs to justify its existence. And it definitely was very obvious to go and start a company.
All I hear in the news right now is how hard it is to get chips, how hard it is to get processors. There's almost like a trade war with processors. In fact, in the U.S. right now, I've got buddies in the automotive industry, and they can't produce cars because they can't get chips for the cars. It's amazing that we've come to that. Do you have a perspective on that? How's manufacturing going? Is it not an issue for you? I'm curious as to what's fact and what's fiction.
Fact. It's fact. It's definitely fact, not fiction. Yeah, there's a real supply shortage. And there are lots of predictions on when it's going to end, whether it's going to end end of this year or middle 22 or 2 years from now or in 2 months' time. But the current situation is certainly real, and it's a struggle for everybody. I'm not a supply chain expert, but I guess in the macro level, it's related to the economy doing much better than we predicted, and semiconductors being one of the foundations of the economy, and and this is how it's reflected.
I don't know if this is true or not. My buddy in the car industry, what he say that lended itself at least to the situation he's describing is like the economy goes down a little bit and they're worried about manufacturing cars, or they can't manufacture cars. They couldn't send people to the factories, right? So they don't have a demand for cars. So they essentially break the demand, and then the edge devices, speaking of, get precedent. So all the chips start going to the edge devices. The car manufacturers wake up and they go, oh, we need to start producing cars now. People are going back to the factory. We need our chips now. And they say, no. We've already got contracts now in place for the edge devices. You're later on down the list. And so now they're fighting, trying to get the chips back prioritized for the automotive industry. Where do you think this is going to end? What's your forecast?
I think that if we look a bit beyond the current horizon and the immediate horizon, we're going to see, I think everybody's now realizing how fundamental chips are for the economy. And I think things will not get into equilibrium until we create enough capacity, and then some, that will satisfy all this demand. I think the governments are starting to understand this. And overall, I think we're going to end up in a better situation than we started. But it will take a little while.
So in all that, you're going to be rich then, right? That's what we just said.
Absolutely.
I knew it. We need to partner, my friend, so I can be rich too. My producer, a good friend Kate, wanted me to ask this question. We have a project leader we work with, Lynn Sneed, who's been on the podcast a few times. She's also a business coach. The simple question, you as CEO, leading very complex processor chip, what would you say is the key to a successful project?
The team that is able to identify the right problem to work on, communicate with stakeholders, customers, suppliers, and work on that. Because execution is the king eventually.
What's the saying goes, strategy without execution is hallucination? Something like that.
It's not a phrase in Hebrew, but I can completely relate to that.
What's the phrase in Hebrew?
I don't think there is one.
Oh, okay. All right. I will play one little game with you and then we'll wrap up. This is, I don't know if it translates, but it's called Would You Rather. In other words, you got to pick one or the other. And it's just a kind of fun game to get to know you as both a person, business leader, etc. All right. You ready?
Let's go.
Would you rather run a business or run a development team?
Run a business.
It's because you're going to be rich. I got it.
Not at all.
Yeah. Public sector or private sector?
Private sector.
Private sector. Startup or existing company?
I think that's an obvious one.
I know. Easy for you, right? These are too easy. Startup then, I presume.
Exactly.
All right. Books or movies?
Books by far.
Books by far. Nice. Let's see. I hope your company goes extremely well. I mean, it's extremely fruitful. You're in a great industry, and I think you're at the cusp of a significant transformation in the industry with edge devices, because kind of ending where we started, my point of view is that we haven't even scratched the surface. I would have, if you had asked me 5 years ago, I would have said edge devices are king. And I still think we've got a lot of room to grow, and we're slow from automotive to retail elsewhere. So anyway, this has been fascinating. I wish you well. Thank you for being on the podcast, Orr.
Thank you, Ed. It's been a pleasure.
Thank you so much. And for our listeners, as always, thank you again. Rate us wherever you're listening. Hit us on almartintalksdata@gmail.com. We'd love to hear from you, get you on the podcast. And look, thanks again, guys. We'll see you on the podcast later.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit IBMBigDataHub.com/podcast to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests, and do not necessarily represent the views of IBM. Until next time,
Let's go.
over and out.